Corresponding angles are like this angle and this angle if the two lines I drew are parallel. Okay, so here, if this line and this line are parallel, then the two angles I just circled in red are called corresponding angles. Okay, and the way that works is because if you have a line that's crossing those two parallel lines, then whatever angle you make in the top left corner is going to be the same as whatever angle you make in the bottom in the top left corner down here. So for example, if you have here, I'll draw two parallel lines going in the opposite direction. Let's say we're told these two lines are parallel and we have a line crossing between them. If somebody tells me that this angle is 30 degrees, well, I'm going to say this angle is 30 degrees because it's corresponding. Okay, they're corresponding because if you look at this, just this intersection, just this, like if this is a road, it's two roads that are crossing each other. So if you look at just that intersection, this is the top left angle, right? And then if you look at just this intersection, this is also the top left angle. So that's why I'm able to say, hey, this one's top left and it's 30 degrees. That means this one is top left, and therefore is 30 degrees as well. Okay? So that's what corresponding angles are. So something different, something on a different playing field, it doesn't have to do with corresponding. Interior angles are angles that are on the inside. This is an interior angle, and this is an interior angle. So usually we talk about interior angles when we talk about like five-sided shapes like this. These are all interior angles because they're on the inside of the shape. And so when you're talking about two parallel lines, the interior angles are usually the ones on the inside. Okay, so with interior angles, there isn't a special rule like with corresponding angles. Like this interior angle isn't always equal to both the other interior angles or something like that. What you've got to do with interior angles is use the fact that two interior angles next to each other make a straight line. Right? Because if we have a circle, that's 360 degrees. Right? I don't remember who came up with 360 degrees. It might have been the Egyptians or something like that. But they said if you want to make a full rotation, you're rotating your angle 360 degrees. Now, if two angles are on the same line, like this, then they're not making a 360 degrees, they're making half a circle. So half of 360 degrees makes 180. So that's something we can use to help us with interior angles. Okay, so here's an example of a problem. If I have that this is 20 degrees, and then I'm supposed to solve for angle X over here. Well, I would like to use the fact that corresponding angles are always the same. Okay. Let's try this color. So this angle is in the bottom left of this intersection. Looking at where these two lines cross, this is bottom left. Looking at where these two lines cross, this is bottom left. So these are corresponding, right? That means we can plug in 20 degrees right here because of what we talked about with corresponding angles. Okay. So we use corresponding angles to get us some idea of what sort of angles over on this side. And now that we have two angles that together would make a straight line, this angle plus this angle is half of a circle. So we can say that 20 degrees plus X should make 180 degrees because together this angle and this angle, they make a half of a circle. Okay, so that might be where that 180 thing was coming from that you mentioned. I think that's what you're looking for, is that interior angles. I mean, when you have two interior angles next to each other, they should always add up to be 180 degrees. Okay, so subtract that 20 degrees from both sides, and you got X is 60. So corresponding angles, interior angles, they're not alike in their definitions, but you can use a corresponding angle to help you get closer to solving for a missing interior angle like I just did on that problem.